Okay, so if you've ever stared at a massive engineering schematic for cable trays and just felt completely overwhelmed by all the jargon, yeah, you are in exactly the right place. In this explainer, we are completely demystifying cable tray sizing. We're going to use a super simple, straightforward highway analogy. No complex terminology, just pure logic. By the end of this, you'll have a rock-solid framework to make accurate, confident decisions on your next job site. All right, let's dive right in.
Picture this, right? You're walking through a commercial building. It's only half occupied, recent construction, but when you look up at the ceiling, the cable tray is already completely packed to the brim, or worse, maybe it's literally visibly sagging under the weight. Ouch! It's a super common, incredibly painful scenario that happens when sizing just goes wrong. The infrastructure is basically failing before the building is even running at full capacity. We obviously want to avoid that exact situation, and to do that, we need to stop thinking of our cable tray as just a metal basket and start thinking of it as a high-speed, critical highway for the building's nervous system.
So to build a reliable cable highway, there is a foundational framework we absolutely have to use, and this is sourced directly from industry best practices. It all comes down to what we call the 3 linked checks. These are fill area, load class, and installation conditions. Think of these as the 3 non-negotiable rules for your highway. Because if you miss even one of these checks, well, your tray is either going to run out of space prematurely, or you'll be scrambling to add emergency structural supports right in the middle of construction. Let's break these down one by one.
Check 1. Space available. Basically, the lanes.
To figure out how many lanes our highway actually needs based on the anticipated traffic, we use 3 specific steps. I mean, you wouldn't build a single-lane dirt road for downtown rush hour traffic, right? Same exact logic applies to your cables. Step 1. Review the cable schedule. This is basically your traffic forecast. It tells you exactly how many cables need to travel this route. Step 2. Calculate the fill ratio. You can't just jam cables tightly together. They need breathing room, just like cars need space between them on the freeway to prevent overheating. And finally, Step 3. Use that ratio to determine the required tray width. This converts your big list of cables into a physical dimension, telling you exactly how wide your highway needs to be.
Moving on to check 2. Weight and spans, or the bridge pillars.
So if the first check was about the lanes themselves, this check is all about the bridge pillars holding the highway up in the air. And listen, here is a massive practical pitfall that catches buyers and engineers off guard all the time. Seriously, a shocking number of mid-construction reworks happen just because of this one little detail. You absolutely have to verify the load class at your actual support span, not just the catalog test span. A manufacturer's brochure might show this pristine laboratory test, where supports are perfectly spaced to hold a massive load. But on your actual real-world job site, pipes, HVAC ducts, structural beams, they might force you to space your supports much further apart. And if your pillars are further apart, well, the bridge simply can't hold as much weight.
So the crucial point here is this: ignoring your actual site span distance inevitably leads to failing infrastructure. If you size your tray based on the brochure's ideal conditions rather than your site's messy reality, you're going to end up with sagging trays. And the consequence of that? No way around it, you are forced to bring in crews to install emergency extra mid-construction supports. It's expensive, it delays the whole project, and the worst part is, it's entirely preventable, just by verifying the load class against your actual span.
Our final check, check 3, environment conditions. Think of this as the weather and future.
Your cable highway doesn't exist in a vacuum, right? It exists out in the real world. Installation conditions are factors that must be decided before any specific product is even selected. For instance, are you going to need covers to protect the cables from harsh weather or falling debris? What about the tray depth? And crucially, this is a big one. Have you planned a future margin? Going back to our analogy, building a brand new highway with zero room for future expansion is incredibly short-sighted. A building will inevitably need network upgrades or new power lines down the road. Leaving a margin for future cables ensures you aren't forced to, build a completely new highway just 5 years from now.
Now, let's look at comparing tray types. As you know, not all roads are paved with the same materials. The physical type of tray you select will fundamentally alter how your highway performs. Even if you choose the exact same nominal width, let's say a 24-inch tray, how much load capacity it actually has differs significantly based on its type. Ladder trays, for example, might offer maximum ventilation for heavy, heat-producing power cables, acting kind of like an open grating. On the other hand, solid-bottom trays offer continuous support to prevent tiny, delicate data cables from drooping, but they completely change the weight dynamics and the cooling. You really have to match the pavement type to the vehicles using it.
Bringing it all together into the complete sizing framework.
Okay, so it's not enough to just do the math on paper. The physical materials you source must actually meet your real-world standards. Bringing this all together requires using reliable, standard-compliant building blocks. This is exactly where a manufacturer like Xinma comes into the picture. They provide the exact building blocks required for this sizing framework, manufacturing comprehensive cable tray systems across some incredibly demanding, high-stakes environments. We're talking massive data centers, rail transit systems, industrial plants, commercial buildings. These are places where a failing cable highway would be, quite literally, catastrophic.
And why does this matter for your sizing checks? Well, because the solutions you choose must be guaranteed to be robust. Xinma's products strictly comply with a whole host of major international standards. You've got IEC 61537, NEMA VE1, BSEN 500085, and GB 31251. Basically, by having standardized, rigorously tested materials, the math on your page actually matches the reality on your job site. There's zero guesswork involved.
So there we have it. We've walked through the essential logic together. We've mapped out the lanes with fill area, we secured the bridge pillars with load class and actual spans, and we weatherproofed the whole route with installation conditions. My challenge to you is this: is your next cable highway truly built to last? Next time you review your schedule, just remember your 3 checks. Enough lanes, strong pillars, and plenty of room for tomorrow's traffic. Thank you so much for joining me on this explainer, and I will see you next time.